Hello, in this video we will talk about classification using naivebayes with R. So we know the naivebayes algorithm for classification actually is a supervised learning method similar as other supervised classification algorithms. Classifiers based on Bayes methods also utilize training data to calculate and observe the probability for each outcome. Then we get this probability to predict the new data, which we have not seen, the labeled data. So the main idea is similar as other classification methods. But here we focus on the probability using Bayes method. So this is closely related to Bayes probability. So Bayes probability is based on the likelihood which we have seen the data and combined with a prior probability. So this formula called conditional probability given B of A. So the probability of A given B, which we have seen B. So both are events A and B. And this conditional probability can be calculated with the definition probability A and B, then divided by the probability of B. So this probability of the B is marginal probability and probability of A called prior probability. So if we have not seen the relationship or the data or the likelihood between A and B, so we only what we can do for the probability A is only to calculate from the raw data from the prior probability, from the general knowledge of A. But if we have some relational information of B and A, for example, the probability of B given A, so this is called the likelihood of B. So if we get this information, then the product of these two parts and divided by the marginal probability of B will be the conditional probability of A given B. So this is called the posterior probability of A after we have seen the event B. So this is the prior and this is the likelihood and this is the marginal. Then we get this conditional probability. So this conditional probability also called posterior probability. So this is the basic idea of the Bayes statistic. So from the prior and likelihood, and we get a posterior. So this is update of the probability of A after we have seen the information of B. So if we use Bayesian methods for classification for the span classification, so span means the bad message or bad email like so span contrary to the span is ham. So HAM is ham. So for example, if we get one word in the message, this word is Viagra. So what's the probability of this message is span if this message contains the word Viagra? So this idea can be given with the help of Bayes method. So this is the marginal for the probability of Viagra. So if we look at this table, this is the contingency table of the Viagra words existent in the message and the distribution of the message is a span or ham. So for example, their total 20 message is a span and 80 a ham, their total 100 message. And for the 20 message with a span, there are 4 with a Viagra word and 16 no Viagra word. So this is very clear. It's a contingency table for the two variables. So Viagra yes or no and span has span yes or no. So if not a span is a ham, right? So the right table is the probability based on these counts. So So we back to this formula. This marginal probability of Viagra actually here is 1 of 100, about 0.05. So this is the marginal because their total 195 has no Viagra and 5 has Viagra. And probability of span, we could look at this row, is about 4 of 20. So 0.2 probability for this prior, for general probability for span. And probability of span of Viagra given span. So we have to look at this row. Viagra given span is 4 of 20, right? 4 of 20. Sorry, I have said wrong. The probability of span is 20 of 100, 0.20, 0 of 2, right? And probability of Viagra given span is this row. So Viagra, we look at the span, and Viagra has 4, not Viagra 20, so about 0.2. So it's very clear. So if we multiply with these two and divide with this one, then we can get the posterior of span given Viagra. So this is what we are looking for, because we want to know the message is span or not if we find one word Viagra, these skeptical words in the message, right? So this is the basic idea for classification using Bayes methods. Also, we call them naivebayes. So why we say naivebayes? Because in a message, long message, there are many words. So we have naive idea, presumptions that those words are not, has no relation. Those words are independent. So only we get this naive assumption, we can multiply the probability of each word. So this is possible using this algorithm to classify the message or the email spam or not spam. So if you want to implement a classification task using naivebayes for the message for the email, then there are several main steps we have to do. The data preparation for the cleaning and standardizing text data, and standardizing because sometimes maybe the variable or the features are numerical, so we have to standardize it for the same scaling. But not every project needed to do this. And the data preparation for splitting text documents into words. So this is for each text project have to do, right? And data preparation, creating, training, and test data set. So we only training the model using training data and test the model for the prediction to see the performance of the model. And sometimes we have to select frequent words in this case, because for all the message, if we find all the words maybe 5,000. So if we use all 5,000 features, it's not possible to fill in the memory of the computer. So this is too large for the data calculation. So we have to select the frequent words. Maybe the words only be selected if they have occurrence for at least, for example, 10 messages. So only over this limit, then these words will be selected. Then we can try a model. Actually, using R, it's just one or two functions from the package TM. TM is text mining package. So actually, when you train the data, you do not need to know very details of the Bayes theory from the previous page. Then we can evaluate the model performance and improving model performance. So next we go to RStudio to show one very simple example. We set the working directory, then we can read we can read this file into working space, the data frame. So this is called SMS raw. If we look at this data frame, actually there are 5,559 rows and with two variables. Two variables are type character. This is for the label, right? Ham, span, so, and then the text. So there are only two variables, and we will use this one for the target, for the category or the Y variables, and use text for the feature. And most of the work will be carried out on text variables. Then we transform this type target as a factor variable because we want to do classification. So this will be yes or no, right? Factor 0, 1. And we show this type variable now. Now it's ham, span, and 1, 2, 1, 2, right? Got these factor variables. And we show how many ham, how many span. So there are about 4,008, about 80%. 20% are span, 80% not span. Then we load a library called TM. You have to install this package first. Then use a corpus. So corpus is will combine all these text, this variable, 5,500 rows text variable. We combine into a corpus object, and this corpus actually is a special list type in from the TM package. Then we can print this SMS corpus. So document 5,559. And if we want to look at this details information, you would have to use inspect function. Then 1 to 2, and their metadata and character 23 for the second, and for first is 49. And if you want to read this data, you have to use asCharacter function and use double brackets because this is a list. So this is the first text, first observations text variable, right? Then if you want to read more than one, you have to use apply function. So this function apply to another function to this list object. So you have to use L for the list. So this is the real function asCharacter. So we run this. So the information is first document text is have you are giving a good week, and second is give back my thanks. So next we have to clean up. First, we will transform all the message into lowercase. So we use tmmap. Then this is a wrap function, and inside this is the target object, and this is the transformer. You can use more than one. So here we use toLower. So these three functions combined together, tmmap and content transformer with a toLower. So the result will be assigned to SMS corpus clean. Then the information is all a lowercase. If we look at again, this is original, not lowercase, and this is the new one. For the first text, all lowercase. So next, we have used 3 cleaning procedures. The first is remove number. The second is remove stop words. And the third is remove punctuation. So these are also ready-made functions inside the TM package. So we will run these 3 first. So the numbers is very clear. We do not need to know the information of numbers for the classification, and stop words are very frequently used, for example, and, or, yes, or like these words. So we just use the standard stop words, English stop words. And the punctuation is very like a symbol, the larger than, less than, a bracket, such kind of symbol. So we will remove all these useless elements. Take a while for it. Okay, done. Then next we will do a procedure called stemming. So what is stemming? For example, these 4 words, learn, learned, learning, but they have the same root. So after stemming, they have only one word, learn. Now, so we just load this library called Snowball C. So you have to install this first. And for example, we can see the word stem of these words. So they get the same word. So for the corpus, we will use tmap, then this object we have worked so far, and with function called stem document. So to done. Then next we will strip white space. Because there are too many white space, we have to do this. Then next we will show the cleaned message 1, 2, 3. So now this is original one, right? This is original, and we use the cleaned corpus, not much cleaner, right? Lowercase and no extra elements we do not want. Then our main job is to create a matrix. So this is called a doc term matrix. The document term matrix. Document is the message that we have over 5,000 message, right? Observations. And term means words. Term means words. So after this, then there is a document, the matrix with a row represent observations for the documents, and a column for the words. But of course, the alternative is you can do several procedures together. Use this method. This is another method. We just skip. So next we can create training data, because this is randomly arranged for the 5,500. So we just use the first part, 75 observations for the training, and the last 25% for the test. Then we also will get the label for the target variable, right? So this is from the original data with this type, because we have transformed with fact type. Do you remember? Then this is for the test label. So before we train the model, we look at the table for the proportion of the training and the test, the labels proportion. During the training data, about 86% for ham and 13% for the span. And for the test data, it's very close. These two very close. So, and we can also use a library called word cloud to get some map figure for the corpus. So this is the pre-processed data, and we only show the most frequently words 50. So this is the cloud word cloud for the training data. And if we show the word cloud for span and ham, so we use subset function, get only span and ham message, Then we show the word cloud for both of them. So this is the span. So in the span message, most frequently words like call, text, txt, text, use, stop, price, mobile is. And for the ham message, most frequently words is got, no, now, want, whom. And the next task is to keep the frequent words, because we have over 5,000 available words. So we only need frequently occurred words. But how many? So here we set a limit called find frequent words 5, for example, about over 1,000. So if we set 5, which means at least 5 message has this word occurred. So we only choose those words. If we set 5, they are about 1,000. So this is a reasonable limit. Then we can set this in a vector, and we will show this one 1,139. These are frequent words. So next we can filter out the training data and the test data. We get all the rows, but the columns will be selected based on these frequent words. So the matrix will be smaller, both for training and test data. And next job is to convert the counting to yes or no, because in this document term matrix, the row is for represent each text, and column is for the words of the text. And for the words of the text, the number in the matrix is counts. So how many, 5, 10, maybe 1, over 0, 1 like this. But what we are interested in only for yes or no. No matter you occur 10 times or 2 times for this document, we only use yes or no or 0 or 1. So this is called we create a function called convert counts. Then we can apply this function to this matrix. We will set the margin 2 for the apply function. So apply function will apply a third function for the margin. 2 is for the column. So for both, this take a while. Okay. So next we can train the data and use package called E1071. Load this package and then use naivebayes, only one function. SM train and the label. So this train data is the matrix we have worked so far. After data preprocessing, cleaning, removing unwanted words, and transform to a matrix, the text transform to a matrix, and we also keep the most frequently occurred words in the matrix. So we just run. So very quick. Then we can evaluate, we can predict based on this trained model. This is trained model, and predict this trained model for the test data set. The test data set is also a matrix, right? So this takes a long time for the prediction. It's done. So after predict on the test data, we can show the performance using a G-module's cross-table function. So in the cross-table actually is the predicted results and the true labels. Then we use this set of false for the t and the chi-square, and also false, and we set the label. So this is the final performance or accuracy of the test dataset using this model. So you can see there are 36 misclassification data. So about 1,390, there are 36, about 2.6% wrong. So which means the actual is span but predicted as ham, and actual is ham but predicted as a span. So this is the basic idea, basic procedure for classification for the text using naivebayes. We use this example because naivebayes is most widely used for the text classification, like email, message. Although this algorithms is very simple idea, and it's also used efficiently. And the last step is to improve model performance. You can change hyperparameter associated with several steps. So we do not go into detail here. So thanks for watching.